start with new topic of sphere. See example. Find the equation of sphere which passes through these 3 points and radius as small as possible. Let us suppose that equation of required sphere is this. Since it passes through these 3 points, so definitely these 3 points will satisfy equation of sphere. So it is 1 plus twice u and so on equal to 0. So we can find u, v and w, which is given by this formula. If r is radius of sphere, so we can write r square equal to this. Let us substitute here value of u, v, w. So after simplification, you will get this result 3 by 4 d square plus 2 by 3d plus 1. Now r is minimum, so r square is also minimum. So for r square is minimum, प्रॉब्लम में लिखा हुआ है यहाँ कि रेडियस इज एज स्मॉल एज पॉसिबल. So r is minimum means r square is also minimum. And since by the property of maxima minima, as you learned in your previous classes, the derivative of this r square with respect to d will be 0. So let us find derivative of this r square with respect to d will be clearly equal to 0. So d will be equal to this. And double derivative of r square clearly positive आना चाहिए और ये positive आ रहा है. So therefore r is minimum for d equal to this. So that will implies u v w, yeah, twice u twice v twice w equal to this. Now let us substitute these three value in this equation. So we will get required equation of sphere. Now equation of circle. A circle is the intersection of plane with some sphere through it. As you know very well, this is our equation of sphere and this it is equation of plane. So if we consider a sphere and a plane, and if a plane cuts a sphere, then definitely we will get a circle. So these two equations together represent a circle. For example, determine the center, radius and area of the circle in which this sphere is cut by this plane. The equations of circle are these two. These two together represent a circle. The center and radius of sphere 1 is this, and it is our radius of sphere. Now see this figure here. From the figure we have to find the center of this circle, center, radius and also area. So here P is any point on the sphere. Now the center of circle here is the foot of perpendicular from center of sphere 1 on the plane 2. Now the dr is of normal to the plane. From here we can find the direction ratio. They are 1, 2 and 2. So equation of line through C, clearly this line passes through this point and having direction ratio this. So it is x minus alpha by this and so on. X minus x1 by a, y minus y1 by b, z minus z1 by c. Let us suppose that it equal to k. So from here we can find values of x, y, z. So definitely this point lies on this line. But we have to find coordinates of this point, which is on the plane. So let us substitute these 3 points in equation of plane. So we will get k. Now put this value of k here in equation number 3. So it will be the center of required circle. अब अपने को यहाँ सर्कल का सेंटर मिल गया है. C के कोऑर्डिनेट्स मालूम है. Also CD, it is perpendicular distance of the point C on the plane. Plane का equation मालूम है. It is our equation of plane. So we can find perpendicular distance by our usual formula. ax1 plus by1 plus cz1 plus d upon under root of a square plus b square plus c square. सिंप्लीफाई करूंगे तो रिजल्ट आ जाएगा 4. Therefore dp is here radius of circle. By theorem of Pythagoras, it is under root of cp square minus cd square. It is 3. Now radius of circle is 3, hence we can find area. It is 9 pi square units. Then next is obtain the equation of circle lying on this sphere and having its center at this point. So given sphere is this, center इसका आ जाएगा यहाँ से 1, -2 and 3. The center of required circle is given as 2, 1, -4. Now we can find direction ratio of CM, x minus x1, y minus y1, z minus z1. That is this. So the equation of plane with CM as normal, we can write here ax plus by plus cz plus d equal to 0. K find out करना पड़ेगा, but this plane passes through this point, so k will be this. Just put here value of k in number 2. So the equations of circle, sphere already given था, plane का equation निकाल लिया अपन ने, and these two equations together is the equation of circle. Then next is here, find the equation of circle circumscribing the triangle formed by 3 points, and also find the coordinates of center of circle. The given points are this, this and this. So equation of plane passing through these 3 points is intercept form. The required circle is the curve of intersection of this plane with any sphere through the 3 given points. So first find equation of sphere. Fourth point is necessary, which we take origin for our sake of convenience. So let us suppose that the sphere through the origin is given by this. This passes through the point ABC. We can find U, V and W. So it is our sphere. Hence, the equation of circle circumscribing the triangle formed by these 3 points are given by 1 and 3. That is this and this. Now to find the center of circle. The center of circle is the foot of perpendicular from the center of sphere on the plane. Now center of sphere is this. Direction ratio of normal find out कर सकते हैं अपन. We can find again equation of perpendicular to the plane passing through these 3 points. And any point on this line is given by this. But this point is the center of circle, then it must lie on the plane. So we can find value of k. It is our value of k. Now putting this value of k in equation 4, we can find center of circle. So friends, let me stop here now. We will continue in next lecture.